Good morning, everybody. Today we'll be having a quick insight into what are preferred numbers in machine design. Now, like we have discussed in the previous video, there is a term that is called as standardization. The standardization conforms to a set of obligatory norms to which various characteristics of a product they should conform. So, this standardization term came into existence and it has been practiced by all designers or all practitioners across the world so as to avoid monopoly of a single product. Now, monopoly is a term wherein if you are not using standardized products, that does not allow interchangeability at any stage of your product life cycle. That means that if a product has been designed and there is a failure of a certain part or if it has to be replaced, if they are not standard products or if they do not conform to a standard set of dimensions, product characteristics, power specifications, etc., then it will be very difficult to uh, replace it by another product of a similar type. That means it will create a monopoly of the individual component in such a manner that it has to be replaced by the parent company itself. So other companies or other vendors who are manufacturing a similar product or a better quality product under the same specifications do not get a chance to actually use it or sell it in the market. Now, preferred size is one basic concept of standardization where a designer needs to specify these are used when a designer needs to specify sizes which may include different parameters like power, load, size, etc. of a product. Now, French engineer Charles Renaud was the first who introduced it, and the system or the entire system of preferred numbers or the usage of preferred numbers is based upon geometric progression. So, if you look at the series of preferred numbers, the preferred numbers are of two types. One is basic and the other one is derived. A basic series means those series which are well designated, well in use, well in practice, and you only need to use them or specify them uh, at the time of their usage. So if we see R5 series, R5 series means it is the fifth root of under root 10. That is equal to 1.58. R10 is 10th root of under root 10, 1.26. R20 is 20th root of under root 10, 20th root of 10. So this is 1.12. R40 is 40th root of 10, 1.06. And R80 is 80th root of under root 10. That is 1.03. Now, preferred basic series or any series of preferred numbers are designated by a multiplying factor, that is this phi. This phi is used to clarify or specify the preferred number or the basic series that is being used or that is being practiced. So in this basic series, with the help of one example, we will be seeing how this basic series and how these derived series are actually used in practice. So let us take these models or sizes, whatever it is, the basic specifications are classified according to this basic series type. So let us take a problem where calculate the power capacities based on R20 series starting from 10 kilowatt for 5 models. Now here in this problem, if you look, there are certain specifications. One, it has been mentioned that you need to select R20 series. The second one that is mentioned is it is starting from 10 kilowatt. And the third important concept is that you have to design or specify power capacities for 5 next models. So if you look at the first model will be of 10 kilowatt. So it is mentioned as 10 into 5 to the power 0. Any number to the power 0 is 1. So 10 into 1 becomes 10 kilowatt. So this is 10 kilowatt. Now the second series is, as we have already seen, that it follows the geometric progression. That means the previous number is multiplied by the geometric progression factor. So when we are talking about R20 series, you can clearly see that R20 series means it is 20th root of 10. So this is 1.12. So the multiplying, these are called as multiplying factors. So there are various multiplying factors. It was already mentioned in the problem that you have to follow R20 series. So this is the multiplying factor is 1.12. Here if you see, for the second model, it will be 10 into 1.12 to the power 1. So here it was to the power 0, here it was to the, so this comes out to be 11.2 kilowatt. Adjusting it to the nearest scientific notation. Scientific notation means values less than 0.5 will be the previous number, whereas greater than 0.5 will automatically shift to the new number. So 11.2 kilowatt gets represented as, this is your standard specification for the second model. So for the third model, it is 10 into 1.12 to the power 2. Or you can say that it was 11.2 multiplied by 1.12. It is one and the same. So the previous number multiplied by the geometric progression factor, or here in this case, it is the series factor. So this becomes 12.54, represented as 13 kilowatt. The fourth model, 10 into 1.12 to the power 3. So this is 14.04. This is represented as 14 kilowatt. Similarly, the fifth model, 10 into 1.12 to the power 4. This is 15.74. This is represented as 16 kilowatt. So suppose the problem was you had to design n models depending upon R20 series. So the general specification could be 10 into pi to the power n minus 1. Here you can say for the fifth model, you have fourth power. So here for nth model, you will be having n minus 1 pi to the power n minus 1, where pi is the series which has been mentioned or decided to be used in the set of preferred numbers. So this problem was for 5 models. So you have designated or calculated the power capacities for these 5 models. If it would have been 6, 7, 8, you could have calculated for the next subsequent models. Moreover, in these types of problem, you can see that only the starting model has been mentioned and the series has been mentioned. And accordingly, the entire problem has to be framed and solved. So these types of problems are based upon basic series, where the series is mentioned then and there itself in the problem. Now let us come to a derived series. Now a derived series means this is a state of a problem where the initial size of the product and the final size of the product is mentioned. So if you look at the problem says a manufacturer plans 5 different models between 7.5 to 75 kilowatt, specify power capacities. Next is, there is an expansion from 5 to 9 models, specify new power capacities. So this is the second part of the problem. The first part of the problem, you can see that there are 5 different models between 7.5 to 75 kilowatt. So if there are 5 different models, that means the initial size of the product and the final size of the product, both are given in the problem. So the 5 models have to be such placed that they start from 7.5 and end at 75. Whereas if you look at the previous problem, here the starting point was known and it was for 5 models. There was no end point and the series was known. Here, the series is not mentioned. You are only specifying that you know the first model, you know the capacity of the last model or the fifth model. And why fifth model? Because there are 5 different models planned. So if you look at the basic structure of the problem for preferred numbers, you will see that it is the first model will have a capacity, if phi is the multiplying factor or the geometric progression factor, it will be 7.5 into 5 to the power 0, 7.5 into 5 to the power 1, 7.5 into 5 to the power 2, 3, and 4. Now these are the 5 power capacities of the models. Now this, you can see that it is equal to, this is equal to 7.5 and this is equal to 75, which is already given. So 7.5 into 5 to the power 4 is equal to 75. So you get 5 is equal to 1.7783. Now this is your geometric progression factor. Or you can say that this is your derived series. Now these derived series are not part of the standard series which have been mentioned here. Now these are standard series, and when you are not using the standard series, you can use this derived power series to specify your problem. So 5, if you calculate it, this is fourth root comes out to be 1.7783. So the final power capacities shall be 7.5 into this geometric progression factor or derived series factor to the power 0. So this is 7.5 kilowatt. 7.5 into to the power 5 to the power 1. This is 13.34. This is equal to 13 kilowatt. The next series that you will be getting, you have to multiply 13.134 by this 1.7783, not 13. Okay, so the previous value, or you can straight away put it in this way, 7.5 into this is equal to 23.72. This gets equated to 24 kilowatt. Similarly, the fourth model is 7.5 into 5 to the power 3. This is 42 kilowatt, and 7.5 into 5 to the power 4. This is 75 kilowatt. So these are the 5 model capacities based upon the derived series, and the magnitude of the series or the value of the series has been calculated in this. So in the problems of derived series, you will be seeing that the first and the last module sizes will be known to you, and you will be also knowing how many models have been planned. Now coming to the second part of the problem, it says that there is an expansion from 5 to 9 models. So if there is an expansion from 5 to 9 models, what was 5 here now becomes 9. That means 9 models have to be incorporated starting from 7.5 to 75 kilometers. So look at those 9 models. This is altogether again a new problem. So 5 becomes equal to 8th root of 75 by 7.5. As because for 4 roots, we have seen that for 5 model capacity, this was the 4th root. So for 9 model capacity, this is the 8th root. So this is 1.3335. So the new power capacities will now be 7.5 into 5 to the power 0, 5 to the power 1, 5 to the power 2. Similarly, if you go on calculating, you will have this 1, 2, 3, 4, 5, 6, 7, 8, 9 models which have been calculated, wherein the first model will be of capacity 7.5 kilowatt and the last model is of 75 kilowatt. And this is how the series has to be used, or this is how derived series are used in practice. Now there are 2 considerations in design. There is one aesthetic consideration and the other one is called as the ergonomic consideration. So aesthetic consideration means the beautification of the product, how beautifully or how aesthetically you are representing the product. So if you take the case of a car, then aesthetic considerations means how the tail lines have been designed, how the streamlined structure of the car has been maintained, how are the doors looking, what are the interiors, what are the colors of the interiors. They add to the aesthetic value of the product thereby, and they are not having any subsequent or any great technicalities associated with it. They are mostly related to beautification of the products, and beautification means how they are pleasing, how much they are pleasing to your eyes. Now the next comes ergonomic considerations. Ergonomic considerations are man-machine relationships. So man-machine, if we talk about man-machine relationships, how the components have been placed or how the equipments have been placed in the system, how a man is being able to use it. Like in the case of a right-hander, it is better that this, as we know, in India, we have people maximum working with the right hands. So the right hand has a control of, for example, the indicators of side, whereas the left hand is restricted to using wiper options with the help of left hand. The answer is very simple, that the side indicator will be used more frequently as compared to the wiper indicators. And moreover, if you look, the steering is so strategically placed so that any person of any height, let it be less or more, can be effectively using it. You have, in some vehicles, you have an adjustment for steering height. There are options for adjusting your seat. In some vehicles, you have height adjustments also of the seats that make the usage of your steering, etc., quite handy and comfortable in practice. So these two are considerations in design, and they are a part of the industrial design process. Now, talking about concurrent engineering, previously what the manner in which design process would continue, that the designer would specify the dimensions of the product. He would send it to the production department. The production department would prepare a prototype, then test it, and subsequently manufacture the complete product and send it to the sales and marketing department. The sales and marketing department, after launching it in the market, would come out with a feedback system that what are the possibilities or where the product is being getting negative response, and once again the design process had to be conducted. Now, concurrent engineering is a method of designing where people from different departments, they sit together across a table and design the product. This helps us in having input from various quarters, and these inputs can be effectively utilized during the design phase itself, leaving very less scope for rework. So concurrent engineering is basically a new concept in design, wherein people from different profiles of the same department, like for example, the sales and the marketing personnel is supposed to depend what calculate or evaluate what the customer wants. So depending upon the customer requirement, he also gives his feedback during the design system. When the material is being selected, the manufacturing and the testing department can also give their opinions about the manufacturability or machinability of the selected material. So the material can be altered at this stage. Depending upon customer requirement, the basic design features can also be altered. Reliability and maintenance, they give you about the life cycle as well as the amount of maintenance required for a product. This will help in knowing the design personnel how much life cycle is expected out of it, and lesser the life cycle, greater will be the maintenance, more money has to be invested into it. Ergonomics and appearance, they also form a very important part, because here psychologist comes into play, where he'll be deciding or he'll be commenting about how nice the product is in terms of usage properties. Because the product has to be manufactured, after all, it has to be used by a customer who has not manufactured it, and neither he was a part of the design process. So when he is using it, it should be comfortable and handy to him as well. So those suggestions are given by this department, which looks after ergonomics, aesthetics and ergonomics of the product. Coming to the cost factor is also a very important product characteristic, because this will help in making the product more saleable, because the product has to be manufactured, and after manufacturing it has to be actually sold also. So cost determines what will be the application of the product, or what is the cost to utility ratio of the product that is being designed. And similarly, sales and service, this gives an account of what is the after sales possibilities, what is the after sales service opportunities that the product will be subjected to or the product is liable to. Like, let us take a very small example. If you are manufacturing a vehicle, a clutch does not form a part of the warranty of the product of a car. The reason is very simple, because clutch is independent of product characteristics. It depends upon how the customer is using the clutch. So whereas there are certain products which are a part of your 3 year or 5 year warranty system, but clutch is never sold as a part of your warranty system, because it is purely dependent upon how the customer is using the product first, and the clutch is composed of standard parts, and those standard parts will give you a standard operating characteristics or standard reliability of the product under a given set of operating conditions. So this is all about preferred numbers and their applications, and how these considerations in design and standardization contribute to the design process.